Hi, welcome to section 6.4. What we're going to do is we're finally going to start digging into that negative side lengths for triangles, and we're going to be applying this idea of trigonometry to more than just right triangles. Trigonometry is really cool, but just doing it inside of right triangles doesn't give us enough flexibility to work with, so we want to expand that idea. To do that, we're going to be making angles on our Cartesian plane, the xy axis. So we first need to get an idea of how we want to talk about these angles. So this is so that make sure that we're talking about the angles the same way. There's lots of ways we could draw angles on the Cartesian plane, but we want to make sure that we're always doing the same thing. So we're going to put the corner of our angle right at the vertex, at the origin. That's going to be our vertex. And then we'll put the initial side, the start of our angles, they're always going to start on the positive part of the x-axis. And then we spin around from there. Wherever they end, that is our terminal side. So you can see here I've got an acute angle and I've got an obtuse angle. Both of them are starting on the positive part of my x-axis. If they end in quadrant 1, we end up with acute angles. So all of our acute angles are just in quadrant 1. All of the obtuse angles are in quadrant 2, but we can go farther and we can go into quadrants 3 and 4. Now, this gets us neat things. We can make negative angle measures. If we wanted a negative angle measure, we could go instead of clockwise, if we wanted a negative angle measure, we could go instead of counterclockwise. Counterclockwise is positive. If we go clockwise around this thing and go this direction, we're able to create negative angle measures. So this would be negative 90 degrees. If we wanted something bigger than 210 degrees, 210 degrees, which is bigger than any sort of triangle could ever handle, we'd start at the positive part of our x-axis. We want 210, so that's going to be bigger than 180. But it's going to be smaller than 270. So as accurate as I want you to be with this thing is about that. It just needs to be in quadrant 3. You don't have to be any fancier than that. But that's going to be 210 degrees. Neat. Now, what you might notice is this negative 90 and the 270, they're stopping at the same spot. That must mean they're pretty cool and related to each other, and they are. It is a coterminal angles, angles that stop at the exact same spot. So here I missed the degree measures on these. So negative 40 and 320 degrees are both coterminal angles. If we drew 320 degrees, it would start at the positive part of our x-axis. I know it's bigger than 270, but smaller than 360. So that's going to tell me that it is somewhere in quadrant 3. Somewhere in quadrant 4. So this would be 320 degrees. Ooh. And I'm going counterclockwise, making it a positive angle. We could go, well, instead of going all the way around, couldn't I just go that way? And would that stop at the same spot? Yeah, you can tell because if you add them together, kind of combine them, it's 360 degrees. It's all the way around a circle. So that's negative 40 degrees. We can do the same thing actually with angles that are even bigger than 360 degrees. 430 is 70 degrees bigger than all the way around. So it's like an angle that started here, went all the way around, and then went a little bit further. So this would be a 430 degree angle. But you look at that angle, it's like, why bother spinning all the way around if you're just going to stop in the first quadrant anyway? So it has a coterminal angle that we can use instead that will actually behave exactly the same as 430 because they stop at the same spot. Now you can check to see if things are coterminal by just checking, hey, if we add 360 and add spins to these things, sorry, my degree measures keep going away, are they going to stop in the same spot? Well, I could draw it out. So if I did negative 180 degrees, that'd be starting at the positive part of the x-axis. We always start there. And we go back 180. 210 degrees, I know that's bigger than 90, but it's less than 180, so it is going to start right here and somewhere in quadrant 3. They're real close to each other. They're real close, but they're not meeting at the exact same spot. Their terminal side, the end spot, is not at the same spot. So these are not coterminal angles. If I check 270 and 740, oh man, 740, that's real big. So let me just figure out how many spins are there by just subtracting 360 degrees from it. So that is one spin. So 740 minus 360, that is 440 minus 60, that is 380 degrees. That's still pretty big. Let me subtract one more spin. That's 20 degrees. Those values are the same. This 20 is matching that 20. They must be coterminal. So if we looked at it graphically, do it in pink. Here's our 740. We go around once, and then go around again because I did two spins that I had to take off. And then I went a little bit into quadrant 1. So this pink one is 740 degrees because I go around the whole coordinate plane twice and then a little bit more. But you look at that and you say, oh, why'd you do all those spins? They weren't really necessary. A coterminal angle with it would be just 20 degrees. It'd be much simpler to work with 20 degrees than it would be to work with 740 degrees. So yes, these are coterminal because their terminal side, their end spot, is in the exact same spot. So next, we will be doing a lot of that stuff of like, oh, man, this 830, it's real big. Could we make it smaller? Yeah, we totally could. 830, I want to get that down. I want to make it so that it's a positive value, as small as possible positive value. So something between 0 and 360. So we need to do 830 minus 360 degrees. So 830 minus 360, that's 530 minus another 60. So that's 470 degrees. That's still bigger than 360, so let's do that again. And that gets 110 degrees. So that is a coterminal angle, 110 degrees, that is coterminal with 830 degrees. Negative 520, you're real negative, negative 520. Can't we make you positive? Yeah. So instead of subtracting spins, let's add spins, kind of like undoing the negative spins that were going around. Negative 520 plus 360 is, let's see, that's negative 220, negative 180? No, that's not right. Negative 160? Let me check my notes. Yeah, negative 160. And then add on another spin. It's late. I can't think very well. 200 degrees. So there we go. Now we've got a positive value that's somewhere between 0 and 360, and it's going to be coterminal with negative 520 because I'm adding 360 over and over and over again. And I'm just doing that until it's a nice number. If I had something like 480 million degrees, I could just subtract 360 a whole bunch of times until I get to be something between 0 and 360.